Hello, this is the 2016 Exam 2 Network Section Question 3. So in this one, we've got a skateboard park. We've got 13 activities A through M, and the activities completion time shown in days. Determine the EST of activity M. So activity M is over here. Earliest starting time is the earliest possible time that could start. So it's going to be finding the longest routes to get there. So 1 plus 4 plus 6 would be 11. 1 plus 9 would be 10. So we have to wait 11 hours to start it. So that's going to be 11. You could write days, I guess, but you don't have to. The critical path, so it's 15 days. So we just have to find a route through the graph that takes 15. We know it's 11 plus 3, which is 14, so we don't have to check the bottom one. Through the middle, it would be 3 plus 7 is 10, plus 4 is 14. So through the top, it's going to be 4. 4 plus 2 is longer, and then 5. So 4 plus 4 is 8, plus 2 is 10, plus 5 is 15. So the critical path would be AEIK. Which activity has a float of 2? So activity D has a float of 1. So this here from this vertex to this vertex would take 6 days via the critical path. D takes 5, so it has a float of 1. The BFL route we said was 14. The critical path is 15, so BFL will have floats of 1. We know the CGJM route is also 14, so they have floats of 1. So it has to be H. And in this case, it works out that the CHM route takes 13 versus 15, so it's a float of 2. So activity H has a float of 2. The completion times for E, F, G, I, and J can be reduced by 1 day. The cost of reducing them is that. What is the minimum cost to complete the project in the shortest time? So, a good way to approach a question like these, if you're not sure, is you can write all the routes out. So I'm going to write them here and then transfer them to the other page. So it's going to be A, D, K, A, E, I, K, B, F, L, C, G, J, M, and C, H, M. We're going to write the durations as well. So A, D, K was 14, A, E, I, K was 15, B, F, L was 14, CGJM was also 14, and then CHM was 13. Okay, so those are all of the routes through the graph. And since there's only 5, this is a fairly good way of approaching a question like this. Okay, so we want to reduce the minimum cost to complete the project in the shortest time possible. And we can reduce each of E, F, G, I, and J by 1. Okay. So looking at the critical path, I can reduce something on the critical path. So A, E, I, K. E and I are both reducible. So I'm going to reduce activity I by 1. That's going to bring that down to 14, and nothing else will change. Okay, so I've done with my I activity. That's been checked off, so we'll make a note of that. Okay, now I need to reduce my ADK, AEIK, and BFL and CGJM routes, which are all 14. I need to reduce all of them by 1 if I can reduce it by 1. So if I reduce activity E, that will do this one. If I reduce activity F, that will reduce this one. If I reduce G, that will reduce this one. And if I reduce J, that will reduce, okay. So it looks like activity, the route ADK, which is a duration of 14, there's nothing on that route that I can reduce. So none of these activities can be reduced. So what that tells me is that if I can't reduce a route that is 14, below 14, then the length of the shortest completion time possible with the reductions is going to be 14. So knowing that, I'm only going to reduce my original critical path with 15 by 1. And we already decided we will do that by reducing I by 1 at a cost of 2,000. So that's it. No more can be done. If it worked out that somewhere in here I had the option to reduce maybe K, then I could probably reduce more of them, but it's not a choice. So that's it. Quick question's a good question. The skateboard park project on page 22 will be repeated with 1 extra activity. Activity M will take 6 days at a float of 1 and will finish at the same time as the project. add it to the network. Okay. So it has a 6-day completion time and a float of 1. So what we're looking for is a route that takes about 7 to get to the end. So it has to finish here. And we're looking for a route that's near the end that takes 7 days to finish. So I've seen one. It's usually helpful to highlight the critical path. So in this case, we can see that going from this vertex to this vertex is going to take me 7. Ik is 7. So if I had the route sitting there with an n, then I can see it's going to have a float of 1 because the original route would be 7 and n takes 6, so it has a float of 1. You could do a similar check for the rest of the edges through the graph, but it works out that 6 plus 3 is 9, so it's not really even close. 7 plus 4 is 11, so it's also not really close. So there's only one spot that sort of sticks out that would make any sense, and so that's it there. And the latest possible time that we could start activity n, so 4 plus 4 is 8, so 4 plus 4 is 8 to get to activity n. It takes 6, which would be 14, so I have a float of 1, which means I can do 4 plus 4 to get here, which is 8, and then the float is the difference between EST and LST, which is 1. I know the EST of that is going to be 8, and then the LST must be 9, since I had a float of 1. So the latest time I could start it would be 9 days. So a little bit tricky, but that's the question. Hope that helps, and I'll see you in the next one.